Here we go.
Yay. Good afternoon. Here we are at 7th period chemistry, looking at our chapter 4 test hints for part 1 of the test. We're actually not going to take this as a separate test because we got jammed up with snow days and hit right into midterm exam time, but some of these things are on midterm exam, so I want to make sure we have the videos for you so that you are ready to do awesome on either the test or the exam. And we are starting with number 14. We taped 1 through 13 in the other class, and those will be posted on YouTube and Moodle along with these. So, test hint number 14. What excited atoms do with energy according to the Bohr model. Now remember, you guys are coming in partway through this, so the Bohr model, Bohr was testing hydrogen, looking at hydrogen's emission spectra, trying to explain why hydrogen was doing what it was doing. And in this hint, we want to know what excited atoms do with that energy. Do we know? Yes.
Do they release it as light?
They release it as light. What do they do first?
Jump.
Okay. The what jumps?
Electrons.
The electrons in the atom jump to higher energy levels, so they're excited. And they can't stay there. They're imitating me. They can't stay there, so they jump back and they release that energy. They emit that energy. And a lot of it falls within the visible range of the spectrum for hydrogen, so we can see those colors in the emission spectrum pattern. All right. Number 15. What must happen to atoms to change from an excited state to the ground state? Well, this sounds very much like what we just said.
Give off energy.
They're going to give off energy. Excuse me. They're going to give off energy somewhere within the electromagnetic spectrum. Doesn't have to be just visible light. It could be X-rays, ultraviolet, infrared, radio, somewhere else within that whole spectrum. Question?
What's the basis for like how long an electron will stay at that energy?
It's instantaneous.
Okay.
When it's excited. I mean, it's excited, it instantly gives that energy back, and so on. Okay? Now, if the atom is not being excited, the electron's going to hang out as close to the nucleus as they can be all the time. Okay? Because they're attracted to the nucleus by charge, so they're going to want to stay close to the nucleus. And if we're not zapping it with energy, then they'll just chill that way forever. Yep.
Why? So would they go back down when they're not having energy put into them?
Well, they wouldn't have moved up in the first place.
But so if you're still putting energy into it.
Oh, if you're still putting energy in, it's jumping up, going back. Just over and over and over again, up and back down. One thing I want to point out to you guys that I made mention of in the prior video, I've been noticing this in the summaries. When the electrons of an atom get excited, they jump to higher levels. A lot of you are in your summary making it sound like the electron starts here, and then it jumps up to here, and then it spits that energy out and goes right back to where it came from. It doesn't always do that. The electrons are excited, they go up to higher energy levels, they fall back to some lower energy level. It doesn't necessarily go all the way back down to where it started. Because when this electron jumps up, another one probably fell down in its place, and then this one maybe goes here, and then up. I mean, it's constantly going back and forth. Yep.
Can it ever fall down below where it jumped from?
Yes. It can fall below. If it started at level 2 and jumped up to level 7, it could fall back to level 1. Absolutely. Yep.
So with the lights, they're just constantly going up and
Yes.
down.
Yep.
What would determine if it jumped to like a one energy level or jumped back down to
The amount of energy it had.
that?
And it's not something we could say, this electron's going to do this. It's
Like, what would determine if we're going to jump down to like one energy level or a lower energy?
well, the electrons want to be as close to the nucleus as they can. So if there's space close to the nucleus, they'll go there. Okay, they'll spit off that energy and go there. This is a pretty simplistic view of quantum mechanics. We can't tell exactly what any one given electron is going to do. but they will be they're attracted to the nucleus because of the charge, so if they can get closer, they will. Okay. Number 15? 16. The concept of the quantum ladder and where it places electrons in an atom. I love this picture on the test. I think that's probably all. Okay. Thank you. So we have the nucleus here, and we have these various energy levels, and we know that an electron could be here at this energy level. An electron could be here at this energy level. Where can an electron not be?
The nucleus.
It cannot be here,
It can't be between.
and it can't be in between energy levels. It's either at an energy level or not. It can't go all the way back into the nucleus, and it cannot be between the rungs of this quantum ladder. Okay? It can't be between energy levels, because it only absorbs a certain amount of what? Gives off a specific amount, definite amounts of energy in each jump. Number 16, no. Number 17, Louis de Broglie's research and how it affects the atomic model. Who? Louis de Broglie. This is one of those, all of the following are true about Louis de Broglie's research except. Okay? Now, Louis helped us understand much more about matter and how it's kind of put together on the inside. If you remember the animation from the online textbook that we looked at last week, Louis merged those two equations that we have. You'll see